I am very happy to introduce our last speaker of the year. He's Augusto Rapalini from Buenos Aires, Argentina. And the title of the talk is Magnetic Polarity of the Upper Cretaceous Chorrillo Formation, Argentina. Geochronologic Constraints on the End of the Dinosaurs Era in Patagonia.
Okay, thank you very much, Florencia. Thank you very much to all of you for being here. And I am very, very honored to be in this very nice meeting with so important people, a lot of young, enthusiastic, and high-level people in the community of Paleomag and neighborhoods. So thank you very much. So let's go for the talk. Florencia already read the title. This, as you can see, for the many co-authors, this is a study we are carrying out with Florencia, and it's I would say people from very different backgrounds and specialities come together. I will show you this way. Okay, sorry, I have an okay here that I have to press. It's not moving. Sorry. What happened?
The arrows are not working.
No. It's not changing. Sorry about this.
We are just seeing the first
I should
slide.
stop and
maybe. Yeah.
The other is stop sharing. I'm going again.
Start again. Yep.
And perhaps this in this way, and now.
Okay.
Oh, okay.
Okay, now it's
yeah, now it seems so. Okay, well, this study is only a small branch of a major project supported mainly by the National Geographic Society. The director is a well-known paleontologist, vertebrate paleontologist, mainly dinosaurs, from Argentina, called Diego Pol, who we are very happy because he's now in University of Buenos Aires. The main objective of this project is to study the evolution of the biodiversity and also the environmental changes in Patagonia prior to the KPG mass extinction. More than 80, almost 100 researchers, including students, of course, and technicians, take place because even though the project is nearly ending, it hasn't finished yet. From more than 15 institutions, both in Argentina and other countries. Of course, the majority of them are paleontologists, but there are also sedimentologists, stratigraphers, and paleomagnetists like Florencia and myself. We were contacted by Diego Pol, actually Flor was contacted by Diego Pol because they were very interested in getting some magnetostratigraphic sections in crucial, critical sections because of the fauna and the flora and the age and in which they didn't have precise ages. This is the area where we work. You can see there the star here. You see the arrow? Okay. This is very well in the south of Argentina, and near the southern tip of South America, and close to Lago Argentino, which is a very touristic place over there. And the unit we studied is the Chorrillo Formation. This is a simplified stratigraphic column for Jurassic and Cretaceous units in Patagonia, mainly in the Austral Basin, I would say. And the Chorrillo Formation has been lately, in the last decade or so, assigned to the Maastrichtian. Actually, the area where we carried our sampling and the study is located here, some 30 kilometers or so from the Calafate. And even though it looks very in a very touristic area, actually to reach that area is not so easy. And this is I will show you later on how we did with our sampling, but this is a panoramic view of the section of the Chorrillo Formation that has been studied thoroughly by sedimentologists and very different paleontologists. And so it's a kind of type section, even though maybe it's not stratigraphically taken as that. And it is composed of 500 meters of fluvial deposits, mainly meandriform deposits. They is composed mainly by claystones and siltstones of purple to brown color, which correspond to floodplain deposits. And there are intercalations, as you can see here, of sandstone beds, which correspond mainly to channels or also to bars. All the sequence is nearly homoclinal. It's just softly or slightly tilted to the east between 18 and 28 degrees. And the main importance of the Chorrillo Formation is the abundant and extremely diverse fossil content. Dinosaurs, turtles, crocodiles, mammals, all kinds of invertebrates, mega and microflora. It is amazing, a kind of treasure for many different types of paleontologists. And here are some of them. You can see extremely well-preserved scalp of a crocodile, fossils of arthropod, which is amazing. The monotrema, the oldest monotrema in the same line as the ornithorynx from Australia, but Cretaceous in South America. Of course, the big dinosaurs, Ornithischia, and other, like the Dinosaurs, and also the flora. No? Megaflora here and microflora here. And these are just a few to bring you an idea of how rich is this succession. And there have coming out in the last 5 years or something like that, a lot of papers presenting different evidence. And in this year, 2025, 2 papers, very important papers came out. One, based on the palinofloras, this is Perez-Loinaz et al., 2025. They analyzed the palinoflora in a lot of detail, and they could define 5 different groups along the section. If you see here, the Chorrillo Formation is the section, the lower to up to the upper. And these are the kind of models or sketch of the environmental and ecological and biological characteristics. And as you can see, just from seeing it very, very, very quickly, that nothing seems to have changed too much along the Chorrillo Formation. The environment kept more or less the same. And this is confirmed by the study of paleosoils. There are something like 20 very well-preserved paleosoils along the sequence. This has been thoroughly studied, and I won't get into the details of how this is studied, but with chemical analysis, they can model which was the mean temperature, annual temperature along the succession. And it's, as you can see, it's something like 14 degrees or something like that, but was very, very stable along the whole Chorrillo Formation. And here, the mean precipitation, annual precipitation, and also you can see not very much changes, not too much changes, and they calculate something between 800 to 1300 millimeters per year. So it seems that it was very stable condition from an ecological and climatic point of view. In the meantime, nobody knows, we don't know how long did the Chorrillo Formation lasted? I mean, how long did it take for the Chorrillo, for all those sediments to be deposited? But being conservative, we guess that it could be 1 million years, perhaps more, because of the paleosoils, because of the environment where these deposits occur. So if it was 1 million year, it was 1 million year, or let's say basic stability. So why did we do try to do a magnetostratigraphy? Because the age of the Chorrillo Formation is not very well known. It is based on the fossil content and on stratigraphic considerations comparing with other formations in the Austral Basin. There are not a single tuff intercalated, at least it hasn't been found yet. So not possibility yet just to date a level that could tell a numeric age of deposition. But there is an agreement that it's probably Maastrichtian. And the recent findings of the palynomorph in this paper I have just showed you, they suggest that in the upper section of the Chorrillo Formation, the assemblage of palynomorph are more like to the late Maastrichtian. And there is yet unpublished some detrital circles coming from the base, the middle section, and the top, and they all give very similar maximum depositional age, around 74 million years. This, of course, is the maximum. Chorrillo Formation must be younger than this. And they found a single circle, which is like 66 plus minus 3. Of course, we know a single circle tells very little, but some of the geologists and sedimentologists say, look, it's pointing to be really Maastrichtian and perhaps late Maastrichtian. Okay, so that's the reasons. I shouldn't explain more than that, why to go there and try a magnetostratigraphy. Okay, we did this field trip in March 2024. For you in the Northern Hemisphere, think that for us, this is the end of the summer. And we should have stable conditions, nice conditions there in southern Patagonia. The access was quite difficult. We have to go more than 3 hours, completely out of road. We needed three four-wheel drive trucks, and perhaps you could see there are the trucks. We should go over here, and well, and finally reach the campment. The campment was already established there because the paleontologists had been working there for a few days. And we came with Florentian students and also some sedimentologists. And stop here. This is March 11 was the first day we start working. You see, nice weather, excellent. You see the outcrops of the section, excellent. A problem from the campment to the outcrops to that section, we had to walk over 2 hours in the morning and then 2 hours back in the evening to the campment. Everything by walk. And okay, that was excellent. 11th of March. But this was March 14th. A huge snow, completely unprecedented. Nobody thought of this kind of snow in March. And as you can see, we couldn't do anything. We suspended sampling at that time. Finally, in March 17, even though you see now a blue sky over there, you see snow everywhere because the day before was another huge storm of snow. Well, it was very difficult to go back with the trucks. And the paleontology decided, no, this is becoming worse and worse. We better leave. And we were rescued, let's say, by a helicopter of the army. We had planned something like 50 sites, maybe 40. We could only got 18. So very sad, coming back very sad. Okay, This is a section of the, a column of the Chorrillo Formation with many information, but they are the blue dots or circles, and the orange circles show the sampling sites. As you can see, maybe the lower section is not that bad cover until we get to the middle of the middle section. But then you see a huge gap here, a few sites here, and then no sample in the upper section. So because we didn't have time. I mean, we were only able to sample for 3 days, and we were not able to carry the drill, so we collected rock block samples at 11 sites, and in the not very well, not too massive siltstones, we collected with hydrobronze tubes 7 sites, so 21 cylinders all in all. Finally, we go back to the lab, and with the rock samples, impossible with the hydrobronze, we measure the AMS, and first thing that caught our attention was the bulk susceptibility was quite high, going well into the ferromagnetic realm, let's say. So ferromagnetic minerals have a big influence probably in the susceptibility and in the AMS. Here is in geographic coordinates, here in paleogeographic coordinates, as you can see. K3 becomes perfectly vertical in paleogeographic coordinates. So the fabric is pre-tilting, and it looks as if it is depositional to compactional, but it caught our attention that K1 axes are not distributed randomly, but they are just aligned in the north-south directions. And so we guess there might be some tectonic overprint, perhaps using this classification of Paris, something like a 2A type. But at the same time, if you look at the shelly neck plot, you see that the anisotropic degree is quite high, and there is no actual not correlation between susceptibility and the anisotropic degree, not at least not a very notorious correlation. Okay, so we were thinking about what about the tectonic overprint, and there was a single site, this CH2, that had this fabric. And so we thought, okay, therefore, this could be a site in which the fabric became almost purely tectonic. So we try some anisotropy of remanents, of anisthetic remanents, and the fabric is this, which suggests that actually this is a product of an inverse, or let's say better intermediate, because it should be a kind of permutation between K3 and K2. So maybe it's more an artifact, let's say an artifact, of the mineralogy, single domain magnetite, that really a tectonic overprint. Okay. And something sections analysis. The important here is that, of course, this is also with the sandstones, and fine to medium grain sandstones, and a lot of volcanic metamorphic lithics. That's why the susceptibility was high, probably. Plagioclase quartz, biotite, opaques. The textural selection is moderate, not bad. And we have either carbonatic, mainly in the lower part of the sequence, and argillaceous cement in the top or in the upper parts of the section. There is no evidence of the formation at all. The opaque minerals show the trital textures. So we have this. So we go to the paleomagnetic study. Hydroboron samples can only be treated with high temperature. These are the steps. Those of the rock samples with treated either with high temperature or alternating fields. Not big difference. Here are the side over plots. Actually, in most sites, behaviors were quite good. As you can see, relatively linear to the origin. These are the rock specimens. These are the hydroboron samples. They are not very different. And this here you can see the demagnetization plots of these are the rocks. Sorry, this is with AF demagnetization, and this is thermal. To be something important to be mentioned here is that all magnetization is destroyed by 600 degrees. So by 600 degrees, we have nothing. So it's everything pointing to magnetite or titanium poor magnetite. This is the mean of the of each site. Some have low number of samples, so the statistics is poor. But in any case, we from the 18 sites we rule out 3. 2 from hydroborons and 1 from rocks, because dispersion or unstable behavior. And the others show more or less all the same behavior. As I already mentioned, the unblocking temperatures and the AF, the magnetization fields are compatible with titanium poor magnetite. And we managed to isolate 2 different components, one a soft component, less than 300 degrees, less than 20 milliteslas, we call it A, and in most of the specimens, a characteristics component between 20 and 80 milliteslas and up to 575 degrees. And we also did some KT curves, so a Bergway transition, attesting that we have magnetite in many samples. Well, here, I wouldn't go too much into that because we are having some problems with equipment, with the curves, mainly with the absolute value of the susceptibility. But I only want to show that there is a big drop for the interval for magnetite, and it might be something more, but at least everything is corroborating that magnetite is probably ruling most of the remanents too. Hysteresis cycle and also IRM, traditional, and then obviously the Day-Dunlop plot and the typical PSD characteristics where they fall. The red one corresponds to the hydroborons material. We collected material and not oriented so to perform rock magnetic studies, and these are the rock in blue. And there is nothing surprising that for the siltstones and clay stones, we should have a position a little more closer to single domain than in this one, but that's all. So let's go to the components. And component A here in situ is here. This is the mean of all. It's a mean of samples, and overlaps with the reference direction of the last 5 million years in situ. So very easy to interpret. This is a recent acquired magnetization, all a single polarity, normal. And of course, if we then correct it, this goes far away, very far away from the 70 million year reference direction. So no problem. Nobody would expect something different from component A. Our target is component B. And component B show a mean direction that is not consistent with the reference direction, but is not either very far away. The problem here is that we are not able to make any tilt test because the sequence is basically homoclinal. So the difference are very, very minor in the statistics before and after bedding correction. And one thing is, okay, but we didn't even get any reversal here. And when we compare with the 70 million year after bedding correction, okay, it doesn't, it's not consistent either. So here, if we want to get or to produce or to give some information on the age, a kind of magnetostratigraphic study, we should be try to be sure that this direction is not a secondary magnetization. I'd like to show you that that I don't know if you see it, it went from black, some of the directions went to red. Those correspond to the hydrobronze tube, so the same directions. Okay. But if we see the component A and component B in situ and bedding corrected, those are the mean directions. And if we, let's compare the bedding corrected direction for component B with the reference direction. This take it from the Torsvik et al. Curve, and if you can see, the big difference is in inclination. So is it possible that we have an inclination error? And we remember the AMS. The AMS was a kind of compactional AMS. And so we look further into this, and we plotted here. This is the mean side inclination of the characteristic remanents against the foliation shown by the AMS. And as you can see here, sites that give characteristic remanents of high inclination show very, very low foliation. But if foliation grows, then there is a correlation with a lower inclination. So it might be random, but it's also suggesting, hey, do we have inclination shallowing? So we try the inclination elevation analyzing, but first of all, we don't have enough number of samples. And the analysis show some inclination shallowing, but not very much. We need to go to nearly 70 to be consistent with the reference direction. But okay, but our number of samples is probably too small, so we couldn't base on this a definite answer. Why are we so interested in seeing if we have inclination shallowing? Because if we have inclination shallowing, we are pretty sure the remanence is primary. So we go for an isotope anesthetic remanence. These are preliminary results. We have to work more on this with more sites and also with windows of field of a field, but we found, with this only in sample from these 4 sites, high. First of all, very well-defined oblate fabrics, the ARM, high anisotropy degree, and something which is close to be a sedimentary or compactional fabric. So we try to compute a preliminary computation, because this is, of course, we are mixing everything together and trying to get a single value. And so we use the AARM, and according to this very well-known function, yes, equation, and in which, well, you know, these are the relationship of inclinations, and this is K minimum and K maximum, in this case of anisotropy, and A is the particle anisotropy. And we try the protocol set by Kodama and others, but it's very well resumed in a paper by Kodama, and we found an A value, particle anisotropy of 1.47 as the more likely, which means an inclination factor of 0.5, which is not so different to one that is generally assumed when you don't have any information for clastic sediments of 0.6. And here, then we use that. I know this is probably not correct, but it gives us an idea. We use this relationship to correct the inclination of each sample direction. And this is how it ends with the ARN correction. And the direction, the mean direction for Chorrillo becomes almost magically virtually identical to that for proposed from the 70 million years mean reference path for South America, or global path in South American coordinates, by Torsvik. And in order to see this better, we computed paleomagnetic poles for the Chorrillo Formation. This is in situ. This is the path 70, 60, 50 million years, South America, from the global path of Torsvik. And this is in situ. It doesn't fit any. This is bedding corrected. It doesn't fit either. But if we make the inclination shallowing correction as computed, it goes pretty well with the 60 and 70 million year reference poles. But if we are suspect that the reference pole is not as accurate as one might want, we also compute it with a single two robust paleomagnetic poles of Cretaceous, late Cretaceous South America, the Patagonian basalts by Bob Butler in this window of ages, and the Pasa Cuatro complexes of 70 million years. And are those the blue? So the corrected Chorrillo pole is perfectly consistent. So we think we're not going to propose the Chorrillo poles as something to modify any apparent polar wander path, but I guess, or we guess, we together guess that this pole position that after bedding and inclination shallowing corrections is consistent with the reference poles that we take, strongly support the primary origin of remanents. That's what we wanted to know, because then we will give some information about the polarity. And here is the only fragments of the section where we got a polarity which is normal everywhere. As you can see, the coverage is only partial. There are different gaps, mainly here in the upper middle section and the upper section, which we don't have a clue. But normal here, normal here, normal, normal, not a single reverse side, strongly suggests that this corresponds to the upper Maastrichtian, either to the C39, C31 normal, or C30 normal, or both, we don't know. Unless the Chorrillo Formation is not Maastrichtian, which is not discussed anymore now, then we can say with the paleomag and the magnetostratigraphy that is very likely upper Maastrichtian, and deposition occur at least the lower and middle section occur in this time interval, 69.2 to 66.4. So to end, we believe the Chorrillo Formation carries a primary, maybe detrital remanence, and despite the problems with our partially failed fieldwork, we could determine a dominant to exclusive normal polarity for the succession. And considering the stratigraphic, paleontologic, and radiometric constraints, the age of the formation can be confidently assigned to the late Maastrichtian, and perhaps between those ages. And relating to the beginning of the talk, we are seeing that these stable climatic and ecological conditions that I presented seem to have prevailed in southern Patagonia, perhaps up to very close to the end of the Dinosaurs era. So, thank you very much.
Well, Augusto, thank you very much for the talk. Now the microphone is open for anyone who wants to ask questions. So grateful for inclination shadowing.
We finally were lucky, I could say, that something could come out from that only 3 days.
Hi,
Yeah,
Augusto.
sure.
As you mentioned, inclination
Yes.
shadowing correction might not be ideal for your number of directions. Did you also try the new SVEI method of stocks? No, we didn't.
No, not yet. Not yet.
Okay.
Thank you.
Okay. Good idea, though.
Yeah.
Okay. So Dennis Kent? Yeah.
Yes. No, actually, Dennis, no. On top of the Chorrillo Formation, there's another sequence which is shallow marine, and it's called the Calafate Formation. And in the base, in the first few meters, there are still some dinosaurs in the Calafate Formation. So the KPG boundary, at least in that locality, is in the Calafate Formation, and it is not very well defined exactly where, but in the top of the Calafate Formation, there are, how you say, squads, tiburones, how you say,
Sharks?
squads. Yeah. Well,
Some type
there
of
are
sharks,
fishes
I
of,
guess.
yeah, sharks, sharks. There are sharks, and but there is also a problem that all these units, Calafate, Chorrillo, and others, are time transgressive. So you move laterally, and in some locations, the boundary may be higher or maybe lower. But in this location, no. The KT or KPG is on top of the Chorrillo.
Okay. And Marina, as Dennis says, thank you. And Marina asks if you are planning to come back, Augusto.
We are planning to come back. We are, since April 2024, are planning to come back. The problem is money. I mean, it's very expensive to go there. We have to rent three four-wheel drive, and the National Geographic grant has to deal with, you know, 80 researchers, many field trips. Florencia is also working in magnetostratigraphy, also in the late Maastrichtian, but in northern Patagonia. So that field trip was also granted and supported by this grant. And domestic grants were stopped since the new government came into office exactly today, 2 years ago. So so we don't have resources. And going to Calafate, I mean, you have to take a plane, 3 hours flight. Um, it it makes I mean, you need a good grant to do that. So I'm sure Florencia will go back someday, and I hope she will show me the results at that time.
Okay, thank you. Thank you very much, Augusto, for your talk. I am very happy to
Thank you
have you
for inviting
here.
me.
So now, I have to share one more slide, sorry. Uh, just quick reminder that to recommend everyone to check our presentations that are already uploaded to our YouTube channel. We have more than 135 presentations. So that's it. Thank you all for coming.